Hello friends, welcome back. Hearty welcome to you. Let's look at this example related to sequences and series geometric progression. We have been given that A, B, C, D are in geometric progression. We have to show that A square plus B square plus C square multiplied with B square plus C square plus D square is equal to AB plus BC plus CD whole square. Now how to solve this problem? Our approach will be, so take out what is given to us, that A, B, C, D are in geometric progression. So we'll go ahead and write down the geometric progression. So sequence will be like this: A, B, C and D. Let us say that A1 is the first position, first term, second term, third term and fourth term. A1, A2, A3, A4. Let us say that the common ratio of this geometric progression is R. Then I can write down that A1 equal to A, A2 which is equal to B, that's equal to AR. I can also write down A3 is equal to C, which is equal to AR square, and A4 is equal to D, which is equal to AR cube, all coming from the general formula that AN equal to A into R to the power of n minus 1, where A is the first term and R is the common ratio of the geometric progression. So once we understand that, we can convert BCD in terms of A and geometric ratio. We are ready to solve the problem. So let's go ahead now, write down what is LHS. Let's write down LHS, that is A square plus B square plus C square, multiply that with B square plus C square plus D square. Now we'll try to substitute whatever the values we got for BCD in terms of A and R. So my next step will be A square plus B square. What is B? AR. So B square will be how much? B square is A square R square. We'll write down here. Similarly, C square will be A square R to the power of 4. Similarly, D square will be A square R to the power of 6. So this we are going to use now. So I'll just write down there. Then we'll come back here and substitute. B square is A square R square plus C square is A square R to the power of 4, and multiply that with B square. We know just now A square R square plus A square R to the power of 4 plus D square is A square into R to the power of 6. Now, do we see any similarity between them? Can I take anything common here? I see A square R square, A square R to the power of 4. Here I see A square R square, A square R to the power of 4, A square R square. So the second expression is nothing but R square into first expression. So I can take R square common and I can write it as A square plus A square R square plus A square R to the power of 4, multiply that with again A square plus A square R square plus A square R to the power of 4. So now I have something like Z into Z, so can I write it as Z square? It will become R square into A square plus A square R square plus A square R to the power of 4 whole square. Now, if we look at the solution, we have AB plus BC plus CD whole square. So everything should be one term only. Here I have two terms. So what I will do now, I will take this, let us say Z, I will write it as R square Z square equal to RZ whole square. So that will help me to make it into one expression. So I'll do that. The next step will be, then I can write it as, take R inside, I will have A square R plus A square R cube plus A square R to the power of 5 whole square. You should be okay with this, because now this is nothing but r square z square. We have written it as r into z whole square. So r into z, r into a square, r into a square, r square, r into a square, r to the power of 4. Okay. Now let's go to the next step. Then what is a square r? A square r is a into ar. So can I write it as ab? Similarly, what is a square r cube? A square r cube is ar into ar square. So can I write it as bc? Similarly, what is a square r to the power of 5? That is nothing but ar square into ar cube. So can I write it as cd whole square? So that's nothing but what we want, ab plus bc plus cd whole square. So that's one interesting example thought of sharing with you. Thanks for your time and support. Bye for now.